Welcome. In this video I show you HTTP client programs. I'm using the request crate for this, and we will use the server from the previous video to serve our requests. Note that we need different servers for the different programs I'll show you here. The first program is basically the simple most thing. I'm in an asynchronous context, and I use a single command, namely the get command from the request crate, by just giving a URL path as a string reference and thereby doing a get request. Now, notice that this is asynchronous, so I have to await it, and the result can obviously be correct or can be an error result. I handle this with a match clause here. In case of an error, I print the error. In case of an OK response, I get a response object back. That's a response type. And this response type in turn has a method text to get the body as text, which is asynchronous in itself. So I have to asynchronously await it again to get the result. And again, there can be an error, which I just ignore here. Let's see how this works. In the background, I have a server running, the one from the last video. And indeed, I get a good response. Here's the response object and its debugging output. We have headers, content length, and so on. Status is 200. And the body is the string hello max, exactly as we had in the last service. Now let me quickly stop the server and run this again. And indeed, an error happened, and we get as error a connect error because the server is not there. So it's a single call, and we can then handle errors and get the body separately. The next example is essentially the same, except that we want to get the body back as a JSON object. We are using the third JSON crate for this, exactly as we used in the second example in the server video. So we do exactly the same. We handle the error in exactly the same way, but instead of calling text on the response, we call JSON. We prescribe here that we want to have a third JSON value object, and we get the JSON object back. Let me see how this runs. Indeed, I get a good response, and I get a JSON object back. Notice that the value here, of course, is of type value. So that's a JSON wrapper. And I can just print this and could work with it just as a JSON body. Let me also show what happens if I stop the server. Indeed, I get connection refused error as before. The next example is slightly more sophisticated. This time we want to do a post request, and we want to send a body. And we want the body to be JSON, but we want to have a typed JSON basically. Therefore, as before in the server side, we define a struct and use the third crate to have automatic serialization and deserialization. So that's what we have to do for that. Now, to send a post request and actually be able to specify the body, the easiest is to separate this a bit out. So we first create a client. That's an asynchronous client from the request crate. And then we call the post method, which gives us a query builder, basically. Now, giving the JSON method takes this object here and serializes it with its standard serialization above here into a JSON body. The content type will automatically be set. Once we do send, we get a future, which we can await. After that, the error handling is exactly the same. We again parse the JSON body, but this time into a person object. We can print this because we derived debug and can see the result back. Then we run this. Indeed, I get a good response. I get a content type application JSON back because the server sent this. And we get a person object back, directly passed. Obviously, we could have parse errors, but here we don't want to concentrate on that. Let me stop the server. The server, by the way, got a request here. If I run this again, you see a second one. I didn't modify the object because I wanted to keep things simple. Anyway, if I stop the server, I get an error as before. Now we want to use encryption. Interestingly, it is not a lot more complicated to use an encrypted request because you can just do the following. Once you have the client builder, like here, you just have to call a few methods, like here, use Rust TLS, specify the minimum TLS version, say that you don't want to have root certificates, add your CA root certificate here if you want. Say you want only HTTPS, and then build the client, and that's your client. You can just use exactly the same way. You use the URL HTTPS, but other than that, the code is completely unchanged. Note that I read the file ca.pem here with read to string, and I form a certificate, which is also part of the request module here, and have the certificate for usage here with the add root certificate. Of course, you can also use the built-in root certificates, but that is not what I wanted to do here. See the instructions in the other video for the server side, how to create the ca.pem file together with the server key and certificates. Let me run this. Behavior exactly the same. However, this time we have an HTTPS request, which you basically can't see unless I would sniff the network. In any case, here we have the server, and as soon as I run it, I see another one popping up here. As you can see, using certificates and TLS encryption is essentially as easy as using a normal request, as it should be. The request crate is usually used in an asynchronous mode, but it also has a blocking synchronous client. I presented exactly the same program as before, just in a synchronous context. So I don't use the Tokyo crate here. I just have a regular main function. And all I have to do is that I include or use the client here from the blocking module. Yeah? Except that everything is exactly the same. So I ask for a client builder, set up the TLS certificate and everything. I build my client. I use the same client post, but in the end, I just do send, and I get the result synchronously. Yeah. And likewise, when I have the response body here, I can get the JSON body just by calling JSON. I don't have to do await here. Other than that, it's exactly the same. It works, and it contacts the server on the other side. Error handling, exactly the same, just synchronously. I hope I have convinced you that the request crate is a pleasure to use to send out HTTP requests. It works in asynchronous mode, which is the default, but it also has a blocking client. It has you covered with respect to TLS and certificates and authentication and everything. We haven't seen everything, but the documentation is, as usual, great. In the next video, we will improve our server and clients with respect to a few more interesting extensions. So the next video still belongs to this series. I hope you enjoyed this one, and see you in the next one.